Here's a fun question. How deep can we safely snorkel? Most of the snorkels that we get at the store are, just these really, really short little tubies that, our head is just barely below the water while we're breathing the air from the atmosphere, all right? But could we make them longer? Could we go deeper? How deep can we safely snorkel? So it turns out we can just answer this question with our famous hydrostatic pressure equation. It's shocking how useful this is. All right, let's give it a shot. So let's suppose that we are snorkeling. Okay, so here is a happy little vacationing snorkeling person. And there they are swimming just under the water. And they're wearing a little snorkel like this, right? Okay. And it turns out that if you're snorkeling, the pressure in your lungs your lungs are actually connected with the atmosphere. So the pressure in your lungs is at 1 atmosphere, right? But you're at a depth in this water, right? And because you're at some depth, there's going to be a new pressure, some pressure in this water. So this is P0. The pressure in the water is P, okay? And it turns out that with our physiology, there is a limit to the difference in pressure in the water between the inside and the outside of our lungs when we're snorkeling that is safe for us. So for example, it turns out that if that pressure difference is greater than about 1/20th of atmospheric pressure, then our lungs have a very difficult time breathing, working, and we could very easily suffocate in the water, which we don't want that, right? Right, we don't want that. So, okay, now, how do we use this with this in order to be able to determine how deep, right? In other words, what is this H? How deep can I snorkel and be safe and my lungs function properly? Okay, well, delta P is this difference between P0 and P, right? In other words, if we just subtract P0 from both sides, okay, so we have P minus P0 equals rho GH, where rho is the density of water, G is gravity, and H is the depth with which you're snorkeling. This P minus P naught is delta P, right? That's the pressure difference between the atmosphere and the water. Okay, so this delta P is going to be just rho GH, right? But this delta P can't be bigger than 1/20th of atmospheric pressure. All right, you may remember that 1 atmosphere is 10 to the 5 pascals. Okay, so in other words, if the change in pressure is greater than 1/20th 10 to the 5 pascals, then we have an issue, right? All right, so remember, what are we solving for? We're solving for H over here, okay? So rho is the density of water, which is about 1,000 kilograms per meters cubed. G is gravity, which is 9.8. And H is what we're solving for. Turns out that if we put this into a calculator and solve for H, it's just about 0.5 meters. This explains everything. This is why the snorkels we get at the store are so freaking short, because if they were any longer, even close to a half a meter in length, then we're talking an inability to breathe while we are snorkeling, which really diminishes the experience.